Hello everyone. This is a brief video on how to balance chemical reactions. So, without further ado, let's get started. Now, why do you need to balance chemical reactions? That's because the law of conservation of mass. It says that matter cannot be created or destroyed. So, what that means is that whatever you have on the left must also have on the right. So let's get started. First up, we have a combustion reaction, and these are always the easiest ones. Just remember the acronym CHO. Now what that means is that first you balance out your carbons. So you have one carbon on the left, one carbon on the right, so we're good. Then you balance out your H's. So you have four H's on the left and two on the right. So we have to multiply this by 2. Let me make that better. There we go. So we have 4 H's on the right, 4 H's on the left. Now, last but not least, you balance out your oxygens. So now we have 4 oxygens on the right, and we have 2 on the left. So we're going to multiply this by 2, and everything is balanced. 1 carbon, 4 hydrogen, 4 hydrogen, 4 oxygen. Now let's get on to the next equation. The next reaction is P4 plus O2 makes P2O4. Or sorry, this should be CO2. I kind of wrote that badly, but anyways. So let's get started. So we have 4P on the left and 2 on the right. So I'm going to multiply this by 2. Now we have 4P on the right and 4 on the left. So that's good. That's what we want. But now we have 6. Oh, this is oxygen. Okay, this is actually oxygen. Never mind. It's my handwriting. So we have 6 oxygen on the right, 2 on the left, so I'm going to multiply this by 3. Now, pretty simple. 6 oxygen, 6 oxygen. Now, let's get on to the third equation. N2 plus H2 makes NH3. Bonus points if you know what kind of reaction this is, like the process of it. So, yeah, let's do it. Now, I should probably erase that because it's pretty confusing. Okay, anyways. So N2 plus H2 makes NH3. Let's start with N because there's only 1 here and 2 on this side. So I'm going to multiply this by 2. Now I have 2N and 2N on both sides, so that's good. Now what about the H? So we have 6H on the right, but we also need 6 on the left. So multiply this by 3. 3 times 2 is 6. So pretty easy. By the way, if you said that this reaction is the Haber process, then you are correct. Bonus points for you. Now, the fourth equation is the creation of Kcl salt. We have 1 potassium on the left, 1 on the right, so that's good. But chlorine, we have 2 on the left and only 1 on the right. So I'm going to have to multiply this by 2 to have 2 KCl. Now, because I multiplied this by 2, now that I have 2 Cl and 2 Cl, so that's good. But now I have 2 potassium and 1 potassium here. So I'm going to multiply this by 2. Now I have 2 potassium, 2 potassium, 2 chlorine, and 2 chlorine. So that's good. That's what I want. Now, this next problem is, it just looks a little bit harder, but it's really not. So I encourage you to pause this video and try it for yourself, because it's a pretty good practice. Now, Let's start with H because there's only one on this side and two on this side. So let's go ahead and multiply this by 2. So now we have 2H and 2H. Let's look at the cyanide, Cn. So you have 2 Cn on this side and 2 Cn on this side. So that's good. Now keep in mind, whenever you see a parentheses like this and then a subscript number, just remember that it gets distributed. So right now we have 2 Cn on this side, and we also have 2 Cn on that side, so that's balanced. Now for copper, we have 1 copper on this side and 2 on the right, and 1 copper on the right side. Now for SO4, we also have 1 on the reactant side and 1 on the product side, so that's pretty balanced. And now we can say that this equation is balanced. So remember that whatever you have on the left, you must also have on the right. And that is how you balance chemical reactions. Pretty simple and straightforward.